Possible rook moves. Now, the thing that made this one a bit different to many of the others that I've done recently is that it uses chess notation rather than anything else. So there's some conversion that needs to take place in order to be able to manipulate the position of the pieces on the board. And doing that in a concise manner was actually quite challenging. So yeah, I quite enjoyed doing this challenge. So straight on with it. So just to skim over the rules, then you're given a n by n chessboard stored in a two-dimensional array. There's some white and black chess pieces on it, so you've got both piece types. A normal chess rook of a given color is placed on the cell square, and it's given in chess notation. Your task is to return all the possible moves the rook can take. I often find it's easier to just look at the test cases in order to see the expected input and output. So let's look here then. So given this board and the start square of B1, which would be here, the possible moves the rook could take would be A1, B2, B3. Now you can go here because -1 would be the opposite colored piece, and you could take it. And C1. Now, of course, you can't move here because that is a piece of the same color. So this argument to this possible rook moves function tells us the side for which we are trying to determine the rook moves. So yeah, that's in this color variable here. So I'll go on with the solution that I came up with. So the first thing I thought to do was to convert this square into x and y coordinates. So quite interesting to note, actually, that this is a string, and you can destructure a string into an array, and then you get each of the characters as an array element. And of course, if you can do that, then you can also destructure into individual variables. So I could have file and rank. So file being the column, rank being the row, and assign that like this. And then console log file and rank. See what we get. Yeah, and we're in this first test case, it's B1, and we've got that nicely destructured into the file and rank variables now. This is quite a handy little shorthand. And of course, given that I can do this, I can just put it up there and get rid of this line of code. Okay, so we've got the file, which is a letter between A and H, and the rank, which is a number between 1 and 8. Now, obviously, the rank is very easy to convert into the row in our array. All we have to do is take the chessboard length, which is going to be, well, it's actually a variable size chessboard because the question doesn't specify that it's an 8x8 chessboard. So we take so hypothetically, if it was an 8x8 chessboard, you could deduct the rank, which would be a value between 1 and 8 from that value to give the row, bearing in mind that A1, let's say, would be the furthest row down in the array. So you'd want to have that mapped to index 7. So you can see how that would work. Length minus the value that we have if it was A1. Now, for the file, quite a cool little trick here, actually, using the parseInt function. So parseInt will convert a string to an integer. I think by default, the radix, or the base of the number system that it expects is 10, because we usually use a base 10 numbering system, but you can specify something else. And for example, hexadecimal, you might want to use base 16, but here we can do something quite cool. We can use base 18 because that goes up all the way up to H. So it will interpret the letters like it would with hexadecimal A, B, C, D, E, F. But it will just continue the logic, G, H, and include those as well. So the letters A through H will, roughly speaking, map to the values 11 through 18. So then we can just deduct 10 from the resulting value to get the index of the column. Just to set a bit of context for the next section where I go through the code, I just wanted to go through at a very high level the concept that I had around how you could have a regular expression to match for the section that we're interested in with regard to where this rook could move. So I've got a board here which represents this test case. 1 being a white piece, -1 being a black piece, 0 being a space. And we're going to be placing the rook that is going to move on the B1 square. So that's the board, white pieces, black pieces. Here's the rook that we're adding, and it's from the white perspective as specified by this 1 here. So this would be a white rook. I've used rooks all over the board here, but they can be any piece because it's white's turn to move, and this here, this green X, is the position of the rook that's being placed on the board, and we have to calculate the possible moves that the rook can make. So if we were to extract the column and the row and express it as a string, it might look something like this. So this would be the column, W, B, space, and then I'm using a 9 to represent the rook that's been placed on the board. So a white piece, a black piece, a space, and then a 9. Similarly, the horizontal section here, I've got a space and then the number 9, which represents our rook, and then a space and then W to represent a white piece. Now, in my mind, I had the idea that you would be able to use a regular expression to match for a black piece, then any number of spaces, the number 9, or the rook that we're placing on the board, I'm using the number 9, and then a number of spaces, and then optionally a black piece. And by writing that as a regular expression, I thought you could then extract that piece of text and then use that piece of text to then know how many spaces in a given direction along that given column or row that you could move, because you'd have that matched piece of text, and then you could split on the 9 and get the left and right section of the text, and then you would know the number of moves that you could go in a particular direction with a rook. So that's what the code is going to be doing. But visually, I thought it would be a good idea just to explain that kind of up front here with a diagram. So I'm using this text example here, which is just to illustrate the idea. But in reality, what I'm going to be doing in the code is using numbers, because what we get in the input array is a 2-dimensional array of numbers, and therefore I will be matching against numbers. But you can see here that this essentially is the exact same thing. We've got a 2, which represents a white piece, 0, which represents a black piece, 1, which represents a space, and a 9, which represents the rook that has been placed on the board. And then for the horizontal direction, you've got, 1, 1, 1, because the board itself has spaces only along this section, and then a 2, which represents the white rook. Actually, that should be a 9 there, shouldn't it? Yeah, 1, 9, 1, 2. Yeah, cool. So I'm just trying to think the best way to approach explaining what I had in mind at the beginning. So I guess this is perhaps a good starting point. So this 9 here represents the position of the rook. So where the rook is. And I wanted to have a regular expression which matches, because it handles the optional taking of the enemy piece quite nicely. So I kind of wanted to have that in regex. Felt like it could handle that quite neatly. So in this regex, if you imagine that 0 represents the enemy, 1 represents a blank square, and then 9 represents the rook that has been placed on the board, you can see that if you're considering a horizontal or a string of pieces, this would actually quite neatly extract the section of the board that could be moved to. So optionally, we could move to the position of taking a single enemy piece. We could hit or move to any of the spaces between an enemy piece, if there is one, and where the rook currently is. And on the other side of, or the other direction, the rook moving in the other direction, you could match, or you could move to any number of empty squares, or optionally a enemy piece. So that's kind of the regex that I had in my mind when I was thinking about how this could be solved. So what I needed to do was to take the input and then extract out as a string the vertical and horizontal section of the board so that I can then match against it. And that's what this part of the code does. So here I've just got a map where I'm mapping over the chessboard. And yeah, it's getting the row, and then given that we have the x coordinate already here, if we're iterating over the rows with a fixed x value, say it was column B, that would be a value of 1, and we would be iterating over that column, each of the rows in that column. So what I'm doing is I'm mapping the values, remembering that they are from -1, 0, and 1. I'm just adding 1 to that in the end, so it becomes the range 0, 1, 2, just because it plays a bit nicer with my regular expression. I didn't want to be messing around with a minus sign in the middle of this regular expression. It just makes it a bit more complicated to handle. And that, I think, explains it roughly. I've got this color in here as well. I'm multiplying by the color. So all that really does is it standardizes the perspective that we're considering the board from, whether you're black or white. So if we are white, then color would come through as 1. And if we multiply all of the -1s and 1s by 1, it's just going to result in the same value. However, if this comes through from the black's perspective, this is going to be -1. And what that will do then is invert all of the -1s and +1s, so that it just means we can consider the board purely from the perspective of either white or black. I think I'm taking it from the perspective of white. Yes, I am, because if we had a 1 in the input, we're going to add 1, that's going to make a 2, so that will never match in this regular expression. So yeah, that means that like colored pieces will always block in this regular expression. So that covers this line, which is for the vertical direction, and this is for the horizontal direction. So we just use y taken from our rank. Yep. And we extract that individual row from the chessboard two-dimensional array, and then we just iterate over all of the items in that array and do the exact same thing. And finally, we just join both of these with an empty string so that we end up with a string of text. Now, of course, the next thing that happens is I'm mapping over those strings and taking the string and applying this match or calling this match method on it to test or extract the matching part of that string, and then getting the match from the result and splitting it on the number 9. So what that's going to do is end up with this section on the left and this section on the right in 2 elements in a returned array, which I'm then destructuring here and here to get the vertical left-hand side of the string and the right-hand side of the string. And if you go horizontally, I've got the left-hand and the right-hand side of that horizontal row as well. So what that actually gives us, if you consider the length of the left-hand side and the right-hand side, that tells us the number of moves in each direction that the rook can move along that particular direction. So it's just a case now of mapping those values into the chess notation for the answers. I forgot to mention, actually, this line of code here is pretty crucial. So given we have the Y and the X values, the input that we get does not actually contain the rook that is placed on the board that we have to consider in the question. So what we do here is just add that into the correct location. And it's 8 to begin with because we're already adding 1 to it here, which is why we're matching a 9 down here. So the final step to this challenge is to take these values that we've extracted, so these strings that represent the match along the vertical and horizontal directions, so specifically the left hand and the right hand side of the string that has been matched, split on the 9. And for each of the characters, we're just going to generate a chess notation for the relevant situation. So here we're going to take the file, which will be the letter B, I think. Yeah, because when we're considering the vertical column, then they're all going to be on the B column. So we know that, and then it's just a matter of calculating the rank. So just using this I value taken from this iterator function here, and just offsetting by the relevant number of rows, I guess. Yeah, we do that for the first match and the second match, so the matching above and below, and then we do it horizontally as well. So in this situation, it is the rank that is fixed because we're matching on a specific horizontal row. And I'm just using this kind of magic string, A, B, C, D, E, F, G, H. And then again, using the X value that we have up here, which is our kind of base point, and then subtracting or adding the I value that we're iterating over on each of these matches to be able to match the certain number of characters to the left or to the right based on the match that we captured earlier. Then finally, we call the flat function because you've got some nested arrays here. And then as a requirement of the challenge, it has to be a sorted list of the chess notation that we get that we return. And in a nutshell, that's pretty much it. I think there's one final piece to the puzzle, which is actually returning the answer. So yeah, I think that covers all of it. It's just a bit more of a compressed down version of the same thing. And let's just run it. And it passes. And there we have it. So I did manage to make it a bit more concise by incorporating a new concept. What I'm doing in this version is essentially the same, but I'm suffixing, when I extract the column and the row, I'm suffixing each of the characters that represents what is in the square with the chess notation up front. So here I'm doing F, which is for the file, plus the length minus T. What was T again? Oh yeah, T is the index of the thing that we're currently considering when iterating over the rows. So this is going to suffix each character with the chess notation for that particular square. Similarly, when considering the relevant row, we're iterating over that row and extracting the item from that row and then suffixing it with the chess notation for that particular square. So now we've got a string which doesn't only contain what is in the square, but it also contains the identifier for the square as well, which means we have to then make the regular expression do the same as it did before, but be resilient to the fact that it has within it the chess notation as well. So you'll see we still have the exact same concept: 0, optional; 1, multiple matches of the 1. And on the other side, multiple matches of the 1 and 0, optional, to match an enemy piece. And just within the brackets, I'm matching any chess notation as well. So A to H followed by a character. And yeah, that works the same as it did, but it extracts the chess notation from the string as well. And this middle section, yes, I modified this so that I don't use a 9 anymore, although I've got a 9 there. That's just a thing that can't be matched. I'm actually matching a 1 here, followed by the specific file and the specific rank of the thing that gets passed in. So I'm actually matching the exact chess notation here to match the rook that was placed on the board. I thought that was a pretty innovative approach. So once that's all done, we've extracted the matches from the column and the row. Then I'm just doing a final match from the text that was extracted to match anything that looks like chess notation. And then that gives us all of the specific squares on the board that solves the challenge. And finally, I'm just filtering out the original rook position because, of course, it has to make a move, so it would not end up on the original square. So yeah, I thought this was a pretty decent way of compressing that solution down. And the final solution, when fully compressed down, looks something like this. So it's pretty short. So when looking through a lot of the other solutions, I mean, this one's pretty short. Not that shortness is the only criteria, of course. Yeah, my one is this one. And yeah, pretty concise. So there we go. I hope you enjoyed my solution. I hope I wasn't a bit too tedious today. I must admit, my brain is a bit frazzled from working on a different solution that I haven't recorded any videos for yet. Around the shortest knight path. Now, the solution for this one is, coming up with a solution was pretty straightforward. It's just, don't want to give too much away, but it's like a breadth first search solution. But I wasn't really satisfied with solving it in an ordinary manner, although it is quite a cool algorithm. I wanted to come up with something more, and I've been digging into crazy sort of heat maps and things and trying to calculate some sort of mathematical solution for solving a night tour. And I must admit, I feel so close to a solution. I don't want to Google it either, because I'm sure this has been solved. But where's the satisfaction in Googling it? Come on, I want to actually solve it myself. But that's coming soon, I hope. If I can come up with some real elegant answer. Yeah, because anyway, I'll leave it for another video. But that's coming soon. So thanks for watching. I hope you enjoyed the video. Please comment below with any questions, issues, ideas. Lots of you have great ideas about various things that I've discussed. And I find it really fascinating to hear from all of you. So I would encourage you to comment and subscribe if you haven't already. So I will catch you later and see you on the next video.